In this video, we will introduce Android Architecture Part 2. Now let's continue our discussion of the Android architecture. Mobile platforms have both advantages and disadvantages in relation to traditional desktop and server platforms. On the disadvantage side, mobile platforms typically have much less computing power at their disposal, less memory, fewer processor capabilities, and less mass storage. However, on the advantage side, they have benefit from designers which have learned from decades of experience. In addition, users expect very different things from the mobile and desktop worlds. Basically, mobile platforms and desktop or server platforms are distinct environments for application development. Let's continue with our discussion of the Android platform libraries. We also see here SGL. This library provides the underlying 2D graphics engine, SQLite, which is a library that provides a powerful and lightweight relational database engine that's available to all apps, and that's also used by Mozilla Firefox and Apple's iPhone for persistent storage. We also see SSL here, which is a library which provides secure socket layer based security for network communication, and a Surface Manager, which is a library which manages access to the display subsystem and seamlessly composites 2D and 3D graphic layers from multiple apps. Now let's take a look at the Android runtime. This section provides a key component called the Dalvik virtual machine, which is a kind of Java virtual machine specially designed and optimized for Android. The Dalvik VM makes use of the Linux core features like memory management and multi-threading, which is intrinsic in the Java language. The Dalvik VM enables every Android application to run in its own process with its own instance of the Dalvik virtual machine. The Android runtime also provides a set of core libraries which enable Android application developers to write Android applications using standard Java programming language. The Android platform provides the environment on which every Android application runs. Each Android application runs its own process with its own instance of the Dalvik VM. Dalvik has been written such that a device can run multiple VMs efficiently. And remember that this is a register-based virtual machine. Some of the core libraries in the Android platform provide most of the functionality available in the core libraries of the Java language, such as APIs, data structures, utilities, file access, network access, graphics, etc. Each Android app defaults to running in its own Linux process, which hosts an instance of the Dalvik virtual machine. Remember that this virtual machine has been designed so that devices can run multiple virtual machines efficiently. This efficiency is largely due to Dalvik executing Dalvik executable DEX-based files, which are files or formats that are optimized for a minimal memory footprint. Take a note that Android starts a process when any part of the app needs to execute and shuts down. Finally, we arrive to the Linux kernel. This provides basic system functionality like process management, memory management, device management like camera, keypad, displays, etc. Also, the kernel handles all the things that Linux is really good at, such as networking and a vast array of device drivers which take the pain out of interfacing to peripheral hardware. Relying on the Linux kernel for core system services, a memory pack and process management, a network stack, a driver model, and security. It also provides an abstraction layer between the hardware and the rest of the software stack. Libraries in Android runtime rely on the Linux kernel for underlying core services such as threading, low-level memory management, a network stack, and a process management, and a driver model. Furthermore, the kernel acts as an abstraction layer between the hardware and the rest of the software stack. This concludes our discussion of Android Architecture Part 2.